trying to find an exact value by using Galapagos. So let me draw a curve. Maybe this time it's going to be a bit off. By the way, I've switched to meters, but I didn't change anything because none of these are quite sensitive in terms of the nature of the exercises. So if we draw a curve, like let's say, I don't know, a line that goes from 0 to 100 meters. And if I zoom into this location, so this is going to be our line. And maybe I can just turn off this grid or type grid and 100 maybe. Okay, so this is my curve set, one curve. And let's put some, I don't know, like write this curve first and then add some circles on top of it. Like let's say 4 and circles, not circles, circle, not this one as well, circle. And if we say, like, I don't know, 5 meters per radius, started to see them there. So if you loft this, and if we cap this, what would we see as its volume or area? Let's go with the volume though. Like grab a panel here for its volume. You see, we are having this volume of 10, and one thing we can do is, why don't we think that, like, what if we want to have like more like a tapered or like a sliding geometry here? And one thing we can do here is to maybe scale these circles by using the same points that we use for these divisions. So right click to this wire display and hidden, connect it to the center, and automatically it goes like that. But let's say we want to keep the first and the last one same. So I have the first and copy this, and let's grab a gene pool. Why gene pool? Gene pool works exactly the same as it's working as a slider in Galapagos. So I can put 3 genes, decimals, like let's say this, and it changes between, I don't know, 0 to 5 to 0.8, because we want things to be going like this, and that's the design goal that I'm having, let's say. And then if I merge this, so the first one, second tree one, and this one, and if we randomize this as our factor and put this in, see, now we are having this interesting sort of geometry here, like a what is, and it has this 1500 or 15,000 blah blah value over there. So one thing we can do here is, maybe if we can say, okay, what is the exact value that we are looking for this geometry? Like let's say we are trying to have, I don't know, like 12,000. So if 12,000 is my aim for the volume, what I can do is I can subtract this value from this one and this one. But what we'll be seeing now is, if this value is positive, or if this value, like the initial volume, is more than our desired volume, it's going to be negative. Or if this is smaller than our desired volume, it's going to be net positive. So we cannot say minimize or maximize unless we put an absolute value, because what this does, it takes every value and takes its distance to the point 0. Therefore, it's going to be always returning positive value, right? So if we grab a Galapagos component now, this is going to be our fitness value. My genome is this guy. I can group this all, and maybe I can just create a view for this one, because views, where's the name view? This one, volume, check. I can name, you can name anything you want it to name. Okay. And if I double click now, and then if I minimize this, solvers, push this on, and if I say start solver, now we started to see it's changing these information. And in the meantime, what you see here is this is changing, and in the same time what you are seeing is this goes really smaller. If you like, it starts with 80 in terms of its difference, and now it's almost there because it's now 0.1, which is something we are looking for, and now it's 0.03 for instance. And this is a great pause moment for me to take a sip of my tea. Obviously, since we are dealing with really like decimals here, we might have some trouble. So why don't we do something as such? Why don't we make it a bit loose here? So I stop my solver. By the way, this is almost an exact solution that I'm looking for. Like, this is almost nothing, right? We almost get our point. But if we say round this value and get the nearest one, so the nearest one is this, right? And if I randomize these three again, right, and then if I say minimize this again and run this solver, oh, then it's not going to respond because we are not taking the nearest out. So we have to take the nearest out. Now I should do the same thing. And if I make the solver run again, you see now all the numbers that we are grabbing here is actually the numbers that have no decimal. So we almost there, and you see it's grabbing a lot of different options while it's changing this, it's ranging in between these scale values. Obviously, if you take out these decimals, things will get a bit better in this end as well. So that is pretty much it actually for this tutorial. And in the next one, we'll take another maybe useful, like another example in which we can think of as a useful example. So I'll see you in the next one.